Lesson 4, electric motor and loudspeaker. This carries on from lesson 3, the motor effect using Fleming's left-hand rule, and it looks at how a electric motor is actually made. The electric motor is simply a coil of wire inside the poles of an electromagnet, and we can see how the effect works using this video clip in the lesson.
A coil of wire around two electrical contacts inside a magnetic field. This causes one side of the wire to move up and the other part to move down.
So if you look on this side, the south side, the current is going upwards, so your second finger will be pointing upwards. On your left hand, the magnetic field is going from north to south, so your first finger is pointing from right to left. And if you arrange your left hand in that direction, you'll see that this side of the coil must be pointing outwards. This other side, the current is going downwards, so your second finger on your left hand, again, are all thumb, first finger and second finger at right angles to each other. The second finger will be pointing downwards. The first finger pointed in the direction north to south. That would mean your thumb would now be pointing into the page, or into the screen in this case, so this point will be going inwards. So therefore this coil would rotate,
which causes the whole thing to spin. It is attached to something called a split ring commutator, which is a clever way of swapping the contacts every half turn to keep it moving in the same direction.
If the split ring commutator was not in place, then it would just do a half turn, so every time this rotates, the current must change direction on, say, the right hand side, otherwise it will just always go into the page. Because this one then rotates around, the side by the S will rotate around. That would be pointing downwards, but for this to go into the page, we need the current when this side of the coil moves over to the north side. We need that current to have changed direction to keep it rotating in the same direction, and that's what the split ring allows to happen. It allows the current to change direction.
You can make the motor go faster by either increasing the current or by using a stronger magnetic field.
So this can appear a little bit confusing, so I'll try to simplify it with a diagram on here. So the point being that in this case, in this orientation on the commutator, the black side is connected to the negative side of the power supply. As this rotates, in this case it's going anti-clockwise. Here we get to the halfway point, it's no connection at all, momentum keeps it spinning. Then it gets to the other side, the side which was connected over here to the negative side. After one half of rotation, this side is now connected to the positive side. So in this way, the current changes direction every half rotation, which will allow the motor to keep rotating in the same direction, because the current will always be going in the same direction when it reaches that side of the magnet. Look at the video on here below to show the operation. That explains it quite well. An application of this motor effect is a loudspeaker. A loudspeaker basically produces a sound. What is a sound? It is a vibration. Okay, so we have a cone which vibrates in and out, and when an electrical signal goes through this coil, it'll be an alternating electrical signal, so changing direction, just like your voice. Producing a sound wave. This current induces a magnetic field in this coil. The coil is placed over an E-shaped magnet, so therefore when this induced magnetic field from the current is created, the direction of that pole on either end of the coil will either be a south pole or a north pole as the current changes direction. So therefore it will be either attracted to this south pole in this E-shaped magnet or repelled from it as the current changes direction, which makes the cone vibrate in and out. That therefore produces a vibration, which is a sound wave. Okay, and some examples of that are given in these exam questions. Again, check the SharePoint for the answers. Okay, lesson 4, a little bit complicated. Might need to look at those videos a couple of times to get the idea, but we will try and look at that later on. Okay, thank you.